Hello, today we're going to be talking about quarks, and specifically mesons and baryons. We'll be talking about the properties of quarks and how they combine to make up mesons and baryons. We're also going to have another look at beta decay and discuss it in terms of quarks. To start with, there are three types of quark you should know: up, down and strange. They have the charges plus 2/3, minus 1/3 and minus 1/3. They also have another quantum number, baryon number. Each of these quarks has a baryon number of plus 1/3. A proton is shown on the right. A proton is one of the baryons, which means its constituents are three different quarks. Specifically, those three quarks are up, up, down. If we think about it, the proton has a charge of +1, so the individual quark constituents must add up to a total of +1. What we have is the two up quarks have a charge of plus 2/3 and the down quark has a charge of minus 1/3, giving us an overall charge of +1. As the proton is a baryon, it must have a baryon number of +1. If again we think about the constituents, we've got up, up, down. Each of these has a baryon number of plus 1/3, giving us an overall baryon number of +1 as expected. Neutrons are similar to protons in that they also contain up and down quarks. The neutron should have a baryon number of +1 and it should also have a charge of 0. Therefore, the constituents of a neutron must be up, down, down. There are three quarks we should know about for the exam: up, down and strange, as well as their anti-quark counterparts: anti-up, anti-down, anti-strange. The quark and the anti-quark would have the opposite charge. Similarly, if each quark has a baryon number of plus 1/3, each anti-quark has a baryon number of minus 1/3. For example, let's look at anti-proton. An anti-proton would have constituents anti-up, anti-up, anti-down, giving it an overall baryon number of -1. The one type of quark we haven't met yet is the strange quark. The strange quark is defined as having an extra quantum number called strangeness. The strange quark has a strangeness of -1, and the anti-strange quark has a strangeness of +1. In addition to baryons, the other type of particle made up of quarks are the mesons. Mesons always contain a quark and an anti-quark. For example, pions are made up of up or down quarks in some combination of quark and anti-quark. Mesons always have a baryon number of 0. I'll leave it to the viewer to work out why this is the case. There are in fact 8 different mesons we need to know about, all containing some combination of quark and anti-quark. Pions always have constituents of up or down, and kaons always have an up or a down, and they always contain either a strange quark or an anti-strange quark. Let's take an example. Pi minus has a constituent anti-up, down. If we think about the charge, that gives it a charge of minus 2/3, minus 1/3, for an overall charge of -1. The charge of these mesons is always shown as a superscript next to the particle. Let's take another example. K plus is made from an anti-strange and an up quark, giving it a charge of plus 1/3, plus 2/3, for an overall charge of +1. Here's a question for you to have a go at. Pause the video and think about what the quark constituents are for the following three particles. Some of the properties of quarks are given to you in the bottom right hand corner. Just bear in mind that every meson should have a quark and an anti-quark, and every baryon should contain 3 quarks. And here are the answers. Okay, so finally today we're going to talk about beta decay. As we know from a previous lesson, in beta minus decay, a neutron changes into a proton with the release of a beta minus particle or a fast moving electron. In beta plus decay, a proton changes into a neutron with the release of a positron. We now have another way of looking at beta decay. In beta minus decay, for example, we can think that a down quark changes into an up quark. This is what causes a neutron to change into a proton. In beta plus decay, an up quark changes into a down quark, therefore the proton changes into the neutron. Here's a question for you to have a go at. Pause the video and write down the answers to this question, and then I'll give you the answers on the next slide. And finally, here are the answers.